In the previous session, you have learned the definition of alkalides, classification based on the prominent heterocyclic moiety present in the alkaloid, isolation from plant, and then structural elucidation of nicotine along with the synthesis. Okay. In this session, you are going to learn the structural elucidation of morphine and physiological importance of alkaloids. Morphine, as I mentioned in the previous session, it belongs to isoquinoline alkaloid. That means it contains isoquinoline heterocyclic moiety. Okay, it is a colorless compound with prismatic structure. It is bitter in taste, insoluble in water, and less soluble in organic solvents such as ether, chloroform, benzol, etc., but more soluble in alcohol and alkali solution. And morphine is used as an analgesic and sedative. Okay, it exerts depression on various parts of nervous system and it is habit forming. You know one thing? Heroin, a diacetyl derivative of morphine, is more habit forming than morphine. Okay, see the structure here. I am showing the structure itself before elucidation so that you can easily understand the elucidation part. Okay, next, structural elucidation of morphine. As I mentioned earlier, the first step is molecular formula. From elemental analysis and molecular weight determination, the molecular formula of morphine is found to be H17, sorry, C17, H19, O3N. Means it contains 1 nitrogen, 3 oxygen atom. Okay, so first step is what is the nature of nitrogen atom? When treated with methyl iodide, morphine forms quaternary salts showing that nitrogen atom is tertiary in nature. So in the nicotine also we have shown, right? There were 2 nitrogen. We shown that both the nitrogen are tertiary in nature. Similarly, here also we have to find out the nature of the nitrogen atom. Here it contains only 1. So when it is treated with methyl iodide, it forms quaternary ammonium salts showing that the nitrogen atom is tertiary in nature. See the equation. Next, there are 3 oxygen atom. So we need to find out the nature of these oxygen atom. So first is presence of 2 hydroxyl groups. You have seen in the structure, right? 2 OH groups. So when morphine is subjected to acetylation, it forms diacetyl derivative, or when it is subjected to benzoylation, it forms dibenzoyl derivative. So this indicates that morphine contains 2 hydroxyl group. Then we need to know what is the nature of these hydroxyl groups, whether they are phenolic or alcoholic. For that, first one, nature of hydroxyl groups. Morphine, when treated with ferric chloride, it gives violet color, which is the characteristic reactions of phenol. And also with aqueous sodium hydroxide, it gives monosodium salts of morphine. Therefore, one of the hydroxyl group is phenolic in nature. We got only monosodium, that means only one OH group is involved in the reaction. That shows that one of the hydroxyl group is phenolic in nature. Then what about the second one? So for that, when it is treated with halogen acid, morphine gives monohalogen derivative. That means the other hydroxyl group is replaced by halogen, and this is the characteristic reaction of alcohol. That indicates that second OH group is alcoholic in nature. That is secondary alcohol. Then what about the third one? We did not see any reaction from the third one. That means it is unreactive. From the unreactivity of the third oxygen and also from degradation studies, it reveals that the third oxygen is in ether linkage. Okay, next. Presence of ethylenic bond. When morphine is reduced catalytically in the presence of palladium, it takes up one molecule of hydrogen. This shows the presence of ethylenic bond. Okay, then presence of benzene nucleus. Morphine on bromination gives monobromo derivative, showing the presence of benzene ring in the morphine. Next, presence of phenanthrene ring. When morphine is subjected to zinc dust distillation, it gives phenanthrene moiety. This indicates that morphine contains phenanthrene ring in the molecule. Presence of cyclic tertiary based system. This is confirmed by the fact that codeine, which is a methyl morphine, is subjected to exhaustive methylation, gives alpha codeine, the formula of which contains one more CH2 group than codeine itself. The nitrogen atom remains intact, that is, it is not lost. If codeine possesses acyclic tertiary amino system, then the product obtained would possess less number of carbon atoms, and therefore there also occur loss of nitrogen. As you can see the equation here. Of CH2 NCH3 group. Okay, codeine meth iodide and codenine meth iodide on heating separately with a mixture of acetic anhydride and sodium acetate gives 3-methoxy-4-acetoxyphenanthrene and 3-methoxy-4,6-diacetoxyphenanthrene along with dimethylaminoethanol respectively. This reveals that there is a presence of CH2CH2NCH3 group in the morphine. From all these facts, the structure of morphine can be constructed as follows. You can see the structure here. Okay. Finally, the structure is confirmed by its synthesis. So the starting material for the synthesis of morphine is dihydroxynaphthalene that undergoes series of reaction to give a compound containing dimethoxy group in the benzene, and in the other ring there are two ketones and one CH2CN group. Then it is subjected to further reaction to convert one of the CO group to OH, and there will be another cyclic ring formation. Then it undergo reaction with the hydrazine and methyl iodide and lithium aluminum hydride to give this compound. Then it further undergo reaction with the sulfuric acid in presence of sulfuric acid KOH, and also base. In presence of base with benzophenone, it gives this compound. And finally we got codenine. Then that, when it's treated with pyridine HCl, gives morphine. And also here we have mentioned 2,4-DNPH, right? That is 2,4-dinitrophenylhydrazine. Even structure is written here. Got it? ACOH means acetic acid, bromine acetic acid. Got it? We need to know the physiological importance of alkaloids. So some of the alkaloids stimulate the central nervous system, while other causes paralysis. For example, caffeine. As I mentioned in the first session, it's an art stimulant. It also affects central nervous system. And some alkaloids act as pain reliever. Example, morphine. It is used as painkiller, that is as analgesic, and also as sedative, and it has depression action on some central nervous system. Okay, and some of the alkaloids are used as local anesthetics. Example, cocaine. It gives local anesthetic action. Got it? And still some of the alkaloids are used against infectious microorganisms. Okay, and some alkaloids are toxic. And many of these alkaloids find use in medical field. And quinine, it is used in the treatment of malaria. Then reserpine, which is isolated from Rauwolfa serpentina. It is used to treat snake bite, epilepsy, insanity, and also as a tranquilizer. You should know that. Then other one, papaverin. It is used as antiplasmodic for smoothening muscles. Got it? The nicotine, which is highly poisonous and is used as insecticides, and it increases the heartbeat. Got it? So next, for more information, you can refer these textbooks. Thank you.